A drone's position vector is given by r of t is e to the t plus e to the negative t, e to the t take away e to the negative t meters, where t is measured in seconds for t between 0 and 5. A plot of the path of the drone is shown below. The drone starts its motion at point A and is at point B when t is ln 3. Determine the position vector for point B exactly. So, well, that is r of ln 3, and therefore that is e to the ln 3 plus e to the negative ln 3, e to the ln 3 take away e to the negative ln 3. That is going to be 3 plus 1/3. Remember our log laws here. Negative ln 3 is ln 1/3, and then e to the ln 3rd would be 1/3. And 3 take away 1/3. So that is going to be 9/3 plus 1/3. And 9/3 take away 1/3. And so that is going to be at 10/3, 8/3. Determine the velocity vector v of t. So we just need to differentiate. So v of t is going to be e to the t take away e to the negative t, and e to the t plus e to the negative t. Don't forget the chain rule, and the negative there is what's given us the plus down here. So, calculate the distance travelled from point A to point B, correct to 0.001 meters. So, the distance is going to be the integral from t is 0, and we were told it was ln 3, is that right? Yep, t is ln 3, so this top limit would be ln 3 of the modulus of v of t dt. So that is going to be the integral from 0 to ln 3 of the square root of e to the t take away e to the negative t squared plus e to the t plus e to the negative t squared dt. We can obviously do that on the calculator, and it will give us 3.036 meters, correct to the 3 decimal places required. After 2 seconds of motion, calculate correct to 0.1 degrees the direction in which the drone is travelling. So what we're after is v of 2, which is going to be e squared take away e to the negative 2 over e squared plus e to the negative 2. And so if we form a triangle, we've got e squared take away e to the negative 2 that way, and e squared plus e to the negative 2 that way. And so it's going to be like that. I'm expecting it to be a bit more than 45 degrees, because this is a bit less than e squared, this is a bit more than e squared. So a bit more than 45 degrees is what I'm expecting. And so let's call that theta. So theta is going to be the inverse tangent of e squared plus e to the negative 2 over e squared take away e to the negative 2. Let's calculate that. And that gives me 46.04. So correct to the nearest 0.1, 46.0 degrees to the positive x-axis. Okay, let's move on. So the last part, and this part is a bit tricky. Determine the Cartesian equation for the path of the drone. So we know that x is equal to e to the t take away e to the negative t. Actually, was that one the plus? Let's just go back and check. That one was the plus. And that y is e to the t take away e to the negative t. So x squared would be, well, we're going to be doing e to the t plus e to the negative t multiplied by e to the t plus e to the negative t. And that is going to give me e to the 2t. Then that's going to give me 1. That's going to give me 1. And so I've got plus 2. And then finally e to the negative 2t. So that one is going to be e to the 2t plus 2 plus e to the negative 2t. And then y squared in the same sort of way ends up being e squared minus 2, e to the 2t minus 2 plus e to the negative 2t. So if we do x squared minus y squared, we get 4. Now that's a hyperbola, and so the actual equation defines something that goes like that, and there'll be another bit over the other side here for negative values as well. So you could actually define a domain for it so that we've only got this part of the curve that we want, but that's not actually necessary for the 3 marks. Now I said that this was tricky. It's not actually that tricky, but thinking of this bit and how to get rid of the t's is quite tricky. So if you think of how to do it, it's straightforward, but if not, you could end up in an algebraic pickle.